so.
It's been really, really helpful.
All right, so we left off trying to dig in deep into the consumer psyche. We dug right into the gut of the consumer to look at his or her preferences on particular goods. So we had this crazy idea of utility that was attempting to measure and estimate the happiness of the consumer and trying to figure out the optimal amount of stuff to purchase. So we went through our beer and pizza example, and we found out that the consumer had a equilibrium combo of, what was it, four beers and 3 pizzas, I think. And the, I guess the trick, I hate to use the word trick, but the way that the consumer went about maximizing utility was to always keep the bang for the buck at its highest level. And that bang for buck concept is the marginal utility per dollar. So we created a column last time that was the amount of satisfaction that you were getting per dollar spent. So let's recap the consumer's problem again. We got lots of problems. In general, on the first day of class, economics, the study of trying to satisfy unlimited wants with limited resources. This kind of ties into what we're looking at here. We'd like lots of beer and pizza. In fact, the more beer and pizza we get, the happier we get, right? So unlimited wants, but limited resources. More specifically to this problem, what is limited? What limits us?
Money.
Money, and what else?
Space.
What do you mean by space?
Space to store things.
Space to store things. I don't have that problem. That type of thing could be built into the problem, but we don't have that.
50 pizzas.
So we had money, so it was income, but there was something else that then kind of defined the space. I wasn't sure where you were going with that. Kind of defined the space for us that constrained us. Make yourself as happy as possible. Consuming is different combinations of beer and pizza, subject to, Corbin said, money, which is a little loose, but okay. But look back to that problem. What else was involved with the solving of the problem to come to say that the consumer's best off at 4 beers and 3 pizzas? And that was our answer. Prices, right. That's the other important component that constrains us. So, we're trying to maximize total utility, subject to what we recall a budget constraint. And in the budget constraint, there is income and the prices of goods. So the budget constraint has income, price of beer, price of pizza, price of whatever. All the prices in the market, technically. But of course, we usually stick to our too-good world for simplicity. All right, so today I want to think about an equation that captures that budget constraint. And I'm not so sure we didn't even write this out before. I don't know, maybe we did. I don't think we did. So what is the budget constraint equation? We had graphing goggles and schedule goggles on yesterday. So what does that equation look like? We have a certain amount of income, and what must be true in terms of our spending? Some of you are in my personal finance class. Think about what do we do in personal finance, kind of income versus spending. They have to what? Equal each other in a budgeting, zero-based budgeting, which goes a little beyond what we're trying to do here. But You've got spending on one side of the equation, income over here. If you spend less than your income, then you have some leftover money, which, by the way, is a good thing. In personal finance, we talk about that. In this particular economic problem that we make various simplifying assumptions, leftover money doesn't give you any happiness. We don't have time period 2 for you to enjoy something next time period for the savings, which we get in a little bit more real world stuff. We could start to make this more complex. So in our little simple world, and this might be more real world to you than it maybe should be, but for a lot of us, whatever's happening today, the amount of money that I have in my wallet, the only way I get happy is that it's all gone by the end of the day because I spent it on beer and pizza, right? So my income equals my spending. Now, let's put that into an equation form. Talk to me in terms of beer and pizza. Income equal to spending on beer and pizza. What does that look like? Formula time.
Just I is equal to.
Oh, I'm sorry, what?
Would it be I is equal to P.
I like it so far.
Price of beer.
We got a ways to go here.
Yeah.
Price of beer.
Price of beer
times
quantity
of beer.
times the quantity of beer. Good. So price times quantity of beer plus price of pizza times quantity of pizza. Good. So it's spending on beer, spending on pizza. Add them together gives you your total spending that is constrained by the amount of money in your wallet, right? So that represents then your budget constraint. All right, now I'm going to push you a little bit harder here on something. I want to take that concept and graph it into this two-dimensional space. So let's put quantity of beer on the vertical axis and quantity of pizza on the horizontal axis. Now, this is a little bit more advanced, not anything beyond what you saw in junior high or high school, but I don't expect you to necessarily remember it. I want you to know it, but I don't expect you to remember it. I might need you to remember it by next Wednesday. But right on the spot, right now today, I do not expect any one of you to remember it, but I want you to know it. So, what do I need to do to this equation to show slope-intercept form in this space?
Well, you set up the quantity of beer as your dependent variable.
Okay, and so talk to me in non-mathematical terms for all of us non-math people, including myself. What would you want to do to this? I think you were saying the right thing. Get it by itself. Yeah, get the quantity of beer over on that side of the equal sign, all the other junk on this side of the equal sign, right? So do it. Get this all by itself. Do a little bit of algebra here. Get QB all on the other side.
The income times the price, the quantity of pizza, and all of that divided by price of beer. Yeah, Sawyer, what are you doing? Income minus this. And then all of that divided by price of
I'm just like, I'm moving everything up here so that this doesn't become like negative. So subtract this. And so that's subtracted.
Get something like that?
Yes.
Lots of strong yeses.
Yeah,
You
it's the
didn't
same.
get it now. So we broke this into this little formula that your math teacher said. You might not have wrote it like this, but y equals mx plus b. You might have used y equals a plus b, ax plus b, whatever. Different forms of it. But this is the slope. This is the intercept of a graph that has the y-axis and the x-axis, just like math class. But now that you guys are more sophisticated, we're talking about real-world stuff, where our x's and y's could be anything of real-world importance, like beer and pizza. And so we've got the slope, we've got the intercept, it all follows that same form. Okay, now let's put some more meat on the bones here and graph it over here. What does this intercept represent? So what is the intercept according to that equation? I over PB. Now going back to our example, I had income of 20, price of beer equal to $1, and price of pizza equal to $2. Talk to me again in layman's terms about what this vertical intercept means. What does it mean, kind of putting this stuff to work?
The maximum number of beers you could buy.
Maximum number of beers you can buy with your 20 bucks, right? So you blew all your money on beer. Whoops.
Big surprise.
That means you get 0 pizza, right? So I blew everything on beer, and I got 20 beers. My $20 at $1 a piece got me 20 beers. Now I can do the same thing down here. What if I blow everything on pizza? You get 10 pizzas. So down here, I've got an intercept of 10, showing that I just blew everything on pizza, which costs $2 a piece. I bring my 20 bucks, I drop $2 a piece, I can get 10 pizzas. And then, of course, I can be anywhere in between. Unless we run into the discreteness problem that somebody brought up, maybe that was Austin, about having a half of a pizza if that's not allowed or something. But let's say that it is allowed, I guess, for graphing purposes. And we could be anywhere along this line, now called the budget line. So the budget constraint is now taking the form of a line, and the consumer is able to be anywhere along that line with the $20. So the $20 allows us to be anywhere along there. So note, consumer can be at any point along the budget line, which we'll just say B line. Now, what is the slope of this line? So what is the slope?
-2.
-2. Okay? That's good from a math hat standpoint. What is it from an econ standpoint? What is it in terms of an interpretation? What is it telling you that about the problem, about the economic problem at hand for the consumer?
2 beers for 1 pizza.
2 beers for 1 pizza. So you're able to trade 2 beers for 1 pizza. Now it seems a little strange here, maybe thinking about the prices. This equation told us that it was the price of pizza over the price of beer. Price of pizza over the price of beer. So if I go $2 over $1, I get my slope. Little negative sign there if we're looking at the slope. So we're seeing something here of a conversion that's helpful. The market gives us prices, but to make efficient decisions, we want to think about our ability to trade goods. Remember Tom and Jen on the island with the fish and the coconuts? And it was more important to think about the trades of physical goods that are going on. Right? And so Tom and Jen ended up negotiating a 2-for-1 trade-off of coconuts and fish. Well, here we've got dollars, but that essentially reflects the ability to trade one good for the other in the marketplace as well. Because check it out, if we think about this a little bit differently, this is two. I'm going to write the notation a little strange here, but hopefully helps more than it hurts, $2 for every pizza and $1 for every beer gives me 2, flip the denominator, multiply times the numerator, dollars over pizza times beer over dollars. The dollars cancel with each other. And it's really telling me that I can trade, as Alex pointed out, 2 beers for every 1 pizza. I can always do that trade, right? Because there's a 2-for-1 trade-off in the market. All right, so this is called the relative price. This is an important thing. We can actually do this with any good. So this is called the relative price. Now, would you call that the relative price of beer or pizza? The 2. So the slope is 2, and we'd say 2, and Alex tells me that we can do 2 beers for every pizza. So would you call that the price of pizza or the price of beer?
Pizza.
Pizza. Okay? Why?
Because you're trading 2 beers to obtain.
Because it's 2 beers to obtain 1 pizza. So normally when we run to Walmart and we see things on the shelves, it gives you the price per unit, right? So if you're buying a bottle of shampoo that runs $6.46, it's per bottle of shampoo. So it's the price of shampoo is $6.46. In this case now what we're thinking is that the price of a beer is, or the price of a pizza is 2 beers. So the relative price of pizza is 2 beers. And this brings us right back to the similar concepts we did with the production possibilities frontier in chapter 2. Same thing with that trade-off. In that case, we were talking about trade-offs in production, not consumption. But we got the similar thing going on here. Okay. So let's do an example. I thought I mentioned shampoo. Let's say the price of shampoo is equal to $6.46. Somebody other than Corbin, give me another good. Give me a good, any good? What? Dinosaur. Oh gosh. Okay, I'm going to make a flat toy dinosaur.
What happens when we?
I don't know how we put a price on a real dinosaur at
See the
this point.
reciprocation.
So, price of D, dinosaurs. So that toy dinosaur, so the toy dinosaur at Walmart is priced at what, Sawyer?
Walmart?
Yep.
$3.58.
Oh, it's just one of those little ones then. Normally when I go to buy those little plastic toys, it seems like I'm always shelling out $15. But that's okay. $3 and how much?
We could do 13.
It's whatever's in your mind. No, I'm rolling with it. Yeah, it's just not what I had in my mind. But
I do 13.50.
$3. No, we're sticking with what you said. That's fine. $3 and what?
58 cents.
58 cents. All right. So now let's look at the what this bottle of shampoo is running. So let's do the price of shampoo over the price of dinosaurs. So price of shampoo is $6.46. Price of dinosaurs is $3.58. And if somebody could pull out their calculator, give me that number to 2 decimal places.
1.76.
1.80.
No, it's 1.8. 1.80.
1.80. Now, interpret that for me. 1.80 what? What is it? 1.8 dinosaurs per bottle of shampoo. So you're giving up 1.8 dinosaurs to buy that bottle of shampoo, right? You're giving up 1.8 dinosaurs to buy that bottle of shampoo. Because at the end of the day, for efficient decision making, it doesn't really matter what things are priced at in absolute terms. It's more important to compare what we're missing out on. That notion of opportunity cost. What are you giving up to get another unit of something? You are giving up 1.8 dinosaurs to buy that bottle of shampoo. And you can do that with anything. So if we put a Snickers candy bar here at $1.25, then we'd be $6.46. I'm giving up about 5 or 4 Snickers bars or whatever, right? So it's the same thing. We're always processing our trade-offs of consumption, quantities. All right, so that's the importance of that. What happens to this guy here if all of a sudden pizza prices drop? They're having a sale. It's getting late and they're about ready to close up shop. Maybe you've seen some places do this. You know, 50% off. Pizza's now $1. What happens to this graph?
You get a slope.
It goes, right. And I'm glad you mentioned the slope, right? So if we look at this thing, instead of being able to buy just 10, I can now buy 20. But I can't buy any more beer when the price of pizza just changes. So that endpoint stays fixed. This one flares out to 20. And the budget line has rotated outward. All right, so let's, I think I'll start with a fresh board over here. And do some changes in the budget line. So movement of the budget line. Movement of the budget line. So let's just kind of stay in tune here with our example. Quantity of beer, quantity of pizza at 10. If there's an increase in the price of pizza, because now the price of pizza, PP1 or PP2, let's call it, is equal to $1, then this thing rotates outward. So the budget line rotates outward around the vertical intercept. You can kind of think of, if we were able to go a full circle, you can think of it kind of swinging out around. It's anchored at the quantity of beer.
Since we already excluded corn.
Don't you mean a decrease in price?
Yes, decrease in price. Thank you. Thank you. Okay. Now, how about if we increase the price of beer? Heaven forbid.
Heaven forbid.
What happens? Increase the price of beer to, let's say, $1 or to $2.
Goes down.
The intercept goes down. So now we're rotating downward this way to 10. So the price of beer equals now $2 because of an increase in the price of beer. What if we really mix things up and have $40 instead of 20?
Increase like
The whole line increases. Good. And is it going to tilt a little bit? A little bit more? Is the slope of that as it goes outward going to tilt a little bit? No, because the price ratio stayed the same. So the trade-offs at the margin are the same. It's still the 2-for-1 trade-off. It just happens to be that you've got more income. And now I'm not going to draw this to scale very well, but let's go up to 40. I don't even know if I said that I had to go up to 40, but I will. So it's a parallel shift out if there's an increase in your income with income now equal to $40 from 20. So a shift outward. parallel shift. And of course, if we lose income, it comes back this way. All right. Questions on the budget line at all? Okay. So we've got that optimal condition that I want to spend a little bit more time on. The budget line ends up showing our ability to purchase goods. Oh, you know, one last thing I kind of wanted to illustrate. Just this little point. What if we're inside this point? What if we're here at, let's just say this is 4 and 9.
We're saving money.
Yeah. You've got unused money, so you're kind of saving money, but if saving money doesn't put it, if you die after time period 1, then extra money does nothing for you. Again, under our simplified economic model. So you will make yourself happier by moving out to the edge of the line, right? But the main thing I wanted to show was that anywhere in this area, anywhere in that area represents an affordable bundle of beer and pizza, right? So this little area here equals an affordable bundle. All affordable bundles of beer and pizza given my income of $20 for this green area. And of course, my consumption possibilities increase when my income goes up to 40. You can see that area would be growing. And if I maintained consumption at point A, I'm not doing as good as I could, because I could be somewhere making myself a little happier with more goods. All right, questions or comments on that part? All right, so recall the utility maximizing condition. And that was the marginal utility of beer divided by the price of beer had to be equal to the marginal utility of pizza divided by the price of pizza. And this is the bang for your buck concept, so that each time we're thinking about where we should spend our next dollar. That changed because of the law of diminishing marginal utility. So each extra gulp gave me less satisfaction. Each additional beer gives me less satisfaction. Each additional pizza gives me less satisfaction. So the law of diminishing marginal utility makes this change as we incrementally add units onto it. All right, so let's shuffle this around a little bit. So let's rearrange our dining room here. Rearranging equation, let's just call it star. Rearranging equation star, we could have the price of pizza over the price of beer equal to the marginal utility of pizza over the marginal utility of beer. Little simple maneuver, right? Switch the position of these two, completely legitimate mathematically. What's this? slope of
Budget line.
the budget line. That was this chunk. So there all of a sudden pops out the slope of the budget line, and it shows us our ability to trade one good for another. This one shows our ability to trade one good for another. Now this thing we haven't really talked about yet. This is your gut. This is that gut feeling of, I'm starting to get hungry, maybe I'd be willing to trade. This is a person's internal willingness to trade one good for the other. Right? So this is the person's preferences. So this is kind of the preference trade-off. Depending on how they like pizza and they like beer. And the word I like to substitute in here is the willingness of the consumer to trade one good for another. There's an old saying in the sales business that you need to have a willing and able buyer. A willing and able buyer. And that kind of ties in here to what's going on for our consumer. In order to get them to purchase maybe whatever good you've got to offer, they need to be not only willing, but also able to do the trade-off, to do the buy, to do the purchase. All right, so to motivate that a little bit, let's say that those two things aren't equal. So what if they're not equal? So let's suppose that the marginal utility of pizza over the marginal utility of beer equals 4. And the price of beer, or the price of pizza over the price of beer is right back to the way we had it before, of equal to 2. So in other words, they're not equal to each other. So not equal. What should the consumer do? What can the consumer do to increase utility, to increase happiness?
Buy better pizza or beer.
Buy more pizza or more beer? Or what'd you say, better?
Better.
Better. We're not going to allow better to enter the equation.
What? That's mean.
No quality changes here. No quality changes. So we need to kind of interpret this one, I think, a little bit more especially. Alex, what did this mean again on the ability? Give me the interpretation. What did the 2 mean? See if you can remember what you said last time. What you said last time was right, so I'm not trying to pin you down too much. Huh? 2 beers for every pizza, right? So there was a 2-to-1 trade-off. So the market allows me to trade 2 beers for every pizza. Now, what is the person willing to do?
4.
So 4 beers for every pizza. So they're willing to do 4 beers for every pizza. But they only have to give up 2 beers for every pizza. Is that a good deal? Yeah. All right? So what can the consumer do? The consumer is willing to give 4 beers for 1 pizza. They are able to only give 2 beers for 1 pizza. So should they make that trade?
Yes.
Yes. Therefore, make that deal. What is the deal? Are they going to be giving up beer and getting pizza, or vice versa?
They're giving up beer.
Giving up beer and getting more pizza. Right, because it's a deal for them to do it. So the answer to this question that might be similar to a homework or exam question you might see, hint, hint, is to increase their quantity of pizza and decrease their quantity of beer. They don't have any more money, bear in mind. They still only got 20 bucks. But they're going to reallocate their budget. In other words, reallocate your budget. Spend your money a little differently. Reallocate your budget. So on the budget line, what would you be doing kind of graphically?
You would be getting progressively closer to the quantity of pizza.
Yeah, you'd be getting closer, I don't know, okay, yeah, I think I tracked it, yeah. I think you said that right. Quantity of beer, quantity of pizza, 20 for 10 trade-off. Didn't draw mine very close to scale this time. But if we're at some point, A, we're saying you will make yourself happier by moving along the budget line that direction. Okay. Oh man, I gotta tell you, I am so tempted to get into chapter 9. It's just so much fun.
So do it.
I love it so much.
Think of how much fun it'll be later.
Exactly.
Yeah, you're delaying your
Like you'll just be
Do
shooting
you think
yourself
time
in the-
period 2 will be that much more gratifying?
You'll just be
than-
shooting yourself in the
than
knee if
time
you have to
period?
cut 9 short if you start now. Yeah.
Yeah, because then you're just going to
Your utility will be minimized if you start it now.
leave class early.
Alright. So,
Your time budget currently would be misallocated.
yeah, we could talk about time allocation. That's a good one too. On 24 hours in a day. Alright, so I won't do that, but I want to lastly connect this to the demand curve. And then we'll be done. So let's just put connecting budget line and optimal quantities to the demand curve from chapter 3. How the heck does all of this stuff relate back to the demand curve? So for this one, I want you to draw 2 graphs stacked on top of each other. 2 graphs stacked on top of each other. We'll just go ahead and put the old, good old pizza here on the horizontal axis, just like before. We'll put on the upstairs graph the quantity of beer, just like before. We'll put a horizontal intercept of 20 and vertical intercept of 20 and a horizontal intercept of 10, just like before. All right, so the next part I want to do is map out a point. We were at how many pizzas in our problem when pizza was $2 and beer was $1? What did we solve for? How many, what was the optimal amount of pizzas?
4 beers and 3 pizzas.
3, yeah, so it's 3, so if that's roughly 5, we'll just say boom. And that's a terrible drawing, drawn to scale apparently. The main thing I want to get is the 3 here. Let's kind of forget about that part, no matter how ugly your graph looks. All right, so downstairs in this graph now, I want to put the price of pizza on the vertical axis. This is going to be the demand curve. And so now we're going to map that information from the upstairs graph to the downstairs graph. I'm measuring the quantity of pizza, so if this is a 3 here, this is a 3 down here. And that was at a price of pizza of $2, so if I just kind of go 1, 2, 3, 4, 5, 6, 7, 8. I have plucked off 1 point on the demand curve. When I decrease the price of pizza to $1, so we were at point A, the consumer is going to be buying more pizza and more beer because there's a lot more consumption possibilities, right? If we think about the affordable bundles, it's now out here somewhere. And so chances are pretty good that pizza is a normal good and going to have a consumption point, let's just say somewhere out here. In fact, I don't want to line it up. Let's just say they go to point. We don't know where they're going to go, by the way, unless we have more information on their preferences. But let's say they go to point B, and they buy 11 pizzas. Now we just map that down into the bottom. And at a price of $1, they buy 11 pizzas. And then just for simplicity, connect the 2 dots, put a big D there, and that is the demand curve. So all we're doing is showing how that type of analysis with the consumer optimization is linked back ultimately to the individual demand curve that a person has for each good. And you can imagine we could take all kinds of prices, 50 cents for a pizza, 75 cents. There's an infinite number of pizza prices that we can pick and get more points along the demand curve. Okay? All right, we'll call it a day. Mark your calendars. I'm letting you out early today.
Like 4 minutes.